Hi, my name is Mateusz Rus. I'm a software engineer. I have been working with Flutter since 2018. Today is my first talk at Fluttercon, so I'm really happy. I share my experience from my last project where we were dealing with legacy code. To start, a quick question. Has anyone here dealt with legacy code? Raise your hand. Would you want to have a serious talk with a programmer who wrote it? Yes, me too. Okay, so legacy code base is something almost every developer faced or will face. So learning from other experience is always valuable. And always we want to try not to do the same mistakes. So let me give you a brief introduction. Our team took over the project that grew from an MVP to a full product. We had to maintain and improve the old code base and address the high technical debt. This scenario is becoming common in software in general and increasingly common in Flutter. And of course, it could happen to you too. Now, let's go to the details. At the beginning, we need to review the entire code base to understand what we are dealing with. Initial code review showed the project has no clear structure or architecture. The code is inefficient and doesn't follow good practices. Also, there is no even proper state management, and there are many deprecated codes and packages. To be honest, code base was very bad. So the first thought was, we need to rewrite it from scratch. But developers' dream of writing perfect, clean code from the start doesn't always match the client's dream of keeping costs low and maximizing profits. We presented the plan for rewriting up piece by piece, but client's reaction was meaningful. The client said that they have big plans where new features in app will be needed. And for now, they cannot afford anything else. So we listed the most important critical areas in the project that must be taken. The client agrees with us to undertake work on these areas, but at the same time, they require to work on new features which might use the old code. So, you have to use your communication skills and address your conclusions to the client, understand their needs, plans for their business, and the current state of the application. Most importantly, share any risks and critical areas that need attention to keep the application working. So, while we're on the same page with the client and know their needs and requirements, we can move on and start to analyze code more deeply. We can divide application issues on several parts: deprecated code, performance issues, app crashes, bad coding practices, and of course security issues, memory leaks, app size issues, UI and UX issues. In the legacy code, we always have to take all of them into account. But first, we should fix these issues that impact client profits and user satisfaction the most. The business owner and user don't care how the code looks as long as the app works well. To sum up, we are in the situation like this. It looks very bad, but technical problems. Okay. It looks very bad, but we have a plan. For this job, we need proper tools. Luckily, Flutter has a very good set of tools for debugging and measuring various aspects of the application. The first tool that I'm sure everyone knows is Dart DevTools. Remember, if you can't measure it, you can improve it. No one likes an app that freezes or crashes. So we should tackle this first. With DevTools, we can check almost every issue mentioned before and get solid data about performance. Using DevTools, we found many problems in the application. Now, I'll show you some examples of how we use them. At first, performance bugs and UI issues. On this slide, we see two screens from the DevTools Performance and Memory tab. The code had many incorrect widgets, like using single child scroll view instead of list view. We can see how jank and memory use decreased after this change. Here is the before, where we used single child scroll view incorrectly. The red bar shows animation jank, and memory usage is almost twice as high. After replacing it with list view, rendering is smoother and memory usage dropped significantly. This is a simple example, but you can use the Performance and Memory tab for any other performance check. Another example is incorrect use of animation. If we turn on the repaint rainbow layer in DevTools, we can see all repaints while the application is running. This helps us find unnecessary UI repaints and optimize the code. On this slide, we see how the repaint boundary widget works. The progress animation causes repaint everywhere, but if we add the repaint boundary widget, only the progress indicator is re-rendered. For those who don't know, repaint boundary is a widget that creates a separate display list and rendering area for its child. If used wisely, it can boost performance. It's frustrating when app takes up a lot of space on your device. So you can generate size files by building the app with the Analyze Size flag. Then go into DevTools, select App Size tab, and open the generated file. After these steps, you can see, as shown on this slide, what takes up the most space in your application. For checking the app size, you can use Apple App Store and Google Play Console too. As I mentioned, we had to deal with outdated code because of issues like null insecurity, lack of strong typing, and poorly chosen packages that created a large technical debt. It was a tough task since much of the code logic relied on nulls. But I have a few tips if you face this challenge. If you are updating your old code to null safety, you can use Dart migrate. You can find step-by-step instructions on how to do it on flutter.dev. The Dart fix command with the dry run flag shows what can be fixed by the Dart analyzer. Run the command to see the changes, and if they look good, run it again with the apply flag to fix the code. Use Dart pub outdated to find old package dependencies and get advice on how to update them. Legacy code is often written without strong typing because Dart allows it. Try to add types whenever possible to improve code safely. Use the Dart analyze command and set up CI/CD process to maintain code quality. Now, how can we check app crashes and memory leaks besides using the DevTools Memory tab? Crashes are very dangerous for your app because they impact user experience and may indicate bad code quality. They often appear on different devices, so use monitoring and error tracking tools like Sentry or Firebase Crashlytics to find where the crashes happen. What about security issues and bad coding practices? We should use static analysis tools which can assist us and our team, but we also should rely on our experienced eye to improve code quality, find all architectural bottlenecks, bad practices, security issues, and so on. And of course, plan the strategy to improve them. All right, since we have fully analyzed the code, we can move on to the project development strategy, keeping business requirements in mind. For this presentation, I have defined 3 project development strategies: fight, flight, and fix. The plane represents flight from refactoring. The 2 swords represents fighting with legacy code. The wrench and gear represent fixing bad code. Fix means improving and refactoring the existing code to improve its quality, performance, and stability. This approach is used when we have time and resources to update the code base. It involves rewriting parts of the old code, cleaning up bad practices, and implementing best practices to ensure the code is robust and efficient. Flight means avoiding changes to the existing legacy code and instead creating new features and modules apart. This approach is used when the old code is too complex or unstable to modify safely. This way, we can ensure the new features work well without risking the stability of the existing system. A simple example: if we have new feature that can be done without the old code, we create it apart using best practices and tests. For example, if we establish a proper architecture, we can make separate folder or package for the new code. In our case, we used a feature-based architecture with separate data, domain, and presentation layers, but you should adjust the architecture to fit your project. Flight is also an option when we have a bug, but the feature is badly designed from scratch and can be fixed. So we have to accept its existence for now. Fight means working with the legacy code to add new features or fix issues. This approach is taken when we need to maintain alignment with the old system or when refactoring the code is not possible. It involves carefully integrating new code with the old one, ensuring that everything works together without breaking existing functionality. As I mentioned at the beginning of the presentation, there was no state management at all in the app. App state was based on Hive models with around 80% of data coming from one single backend endpoint. As you can guess, this causes many problems. One of them was when we wanted to use some data, we had to rely on Hive model, which was updating across the whole app. So we built a bridge between the Hive model, state management solution, and new code. We used Riverpod, but of course you can use anything you want. Riverpod notifier listens for changes in the model and updates its value. This way, models in the old code could be updated. This approach is a fight because we don't eliminate the main problem with Hive models, we just bypass the solution. If a client needs fast feature development because of, for example, unexpected business need, and we see an opportunity to easily add new code to the old one, like using a few if statements, it's good to consider this option. This can be flight or fight, depending on whether we need to touch the old code. Okay, so there was just a few examples. So now I want to present some general conclusions. This table shows the correlation between development time and business needs for deprecated code. Bottom left corner, here we have no time and no business needs. So we can simply fly from refactor for now. Bottom right corner, as our development time increases, we can afford to fight or even fix the legacy code in areas where the business doesn't need it, but we, as developers, want to improve our code. Top left corner. When we have little time, but the business needs a feature quickly, we will probably flight or fight, depending on the code state. The risk of bugs and missed deadlines goes up a lot. And top right corner. This is the ideal situation where we have both enough time and business approval. Here we should consider ethics. So, the upper left corner is where our project is growing fast. The lower left corner is when we have time only for the most important things or when our project is not legacy. The lower right corner is where our project is stable, there is no need for new features, and we have more time for improvements. The upper right corner is when our project has long-term business understanding. They want features done the right way, so they allow more time for refactoring and development. We can interpret the other areas in relation to these edge corners. I think it's very important to explain to the business what fight, flight, and fix mean when dealing with legacy code. When you work with a client, they usually have the final say. But as the project leader, you are responsible for the app. Summary and tips to avoid or maintain the legacy code. So if you are creating an MVP, maintain at least basic structure. And as the project grows, refactor as fast as possible. Use appropriate architecture, good coding practices, lean rules, and so on. To quickly verify the application, we often use packages created by the community. Make sure that package is well maintained. To avoid legacy code, it's important to write tests. Unit, widget, and integration tests ensure your code stays easy to manage and high quality. Communicate to the business if the functionality takes more than expected. But if you're already dealing with legacy code, you must know that technical debt must be paid off someday. Communication is as important as the code. It's good to know when fight, flight, and fix. Of course, this was a brief presentation. So if you want more information, not just on this topic, but also on Flutter and Dart in general, a QR code is displayed on the screen. You can explore my work and find more materials that are already in preparation. For the past 2 years, I have been creating content for the Polish community and recently started sharing my knowledge in English as well. Thank you.